Hi there, welcome to Superphysics, the online physics tuition service. This is question 5 of the WJEC AS Physics Unit 1 exam in May 2016. Question 5, as it says on the front of the paper, is an assessment of quality of extended response. It will take place question 5. So essentially they are looking at your ability to write coherently in a clear, structured format displaying clear levels of scientific reasoning. So, question 5 looks like quite a simple question. Don't particularly give you much, but we have a marble is released from at A onto a curved ramp. The question asks us to explain the energy transfers that take place from the moment it's released to the moment it finally comes to rest. So, if it's released, we can assume that there's zero kinetic energy to start off with. So, imagine someone's holding the ball in place and let go, that will be released. And so, first of all, when the ball is at A, it has a store of gravitational potential energy. And as the marble rolls down the ramp, because it's getting lower, it moves through a height, the amount of GPE decreases, and the amount of kinetic energy increases. So essentially we're saying it gets faster. At B to C, the kinetic energy decreases and GPE increases. So the first thing to write down is talk about the energy conservation. So at A, the GPE is converted to kinetic energy as it travels to B. Okay, so GPE decreases, kinetic energy increases. So you say GPE decreases, kinetic energy increases. Okay, from B to C, kinetic energy decreases and GPE increases as it goes higher again. Now, it's not going to roll back and forth forever, because we also have other elements here about energy being converted to other forms. Okay, so now the reason it doesn't roll back and forth forever is because there's friction between the marble and the ramp, and also a tiny amount of air resistance. So we're going to say, as the marble travels along the ramp, work is done against friction and air resistance. So that work is done, quite a key phrase. It just means energy transferred. So, we can say because work is done against air resistance and friction, at C there is less GPE than at A, because work has been done against friction and air resistance. So every time it rolls back and forth, more work is done, to eventually all the initial GPE at the start is converted to heat in friction, air resistance, and all the energy GPE is converted to heat and at the end, when the ball finally rests in the middle of the ramp, which I think is at B. So the GPE is converted to heat in friction and air resistance as it continually travels along the ramp until eventually all the initial GPE at A is converted to heat. So the ball has 0 kinetic energy and is stopped. And that will explain why the transfers energy from the moment it's released to the moment it finally comes to rest. Okay, part B of the question. A heavy sled moves with a constant velocity, which is in bold writing, when it's pulled by a force of 280 newtons acting as shown. State why the work done in pulling the sled cannot be calculated by simply multiplying 280 by the distance the sled moves. So the work done by a force is equal to the force multiplied by distance in which the force is applied. Okay? So what we need to do is we need to work out the component of this force in the direction of the sled. When the sled's moving horizontally, it's not moving along that line there. Okay? It's moving along the ground. That 280 newtons is not being applied directly in the direction the sled's moving, and therefore we cannot do 280 times by the distance it's moved. Okay? We can also say the force is not being applied in the direction the sled is moving. Okay? It takes 20 minutes to pull the sled a distance of 3 kilometers over level ground. Calculate the mean power needed. Well, power is defined as the rate of work done. Okay? Capital W stands for work done. So first of all, we need to work out the amount of work done. So work done is going to be the force in the direction the sled is applied, the sled is moving, times by the distance it moves. So if we take that 280 newtons there, okay, we're told that's 35 degrees. We want to look at the force in the F direction, in the X direction. So that side of the triangle is the adjacent, so let's label that adjacent. And this is the hypotenuse, and that's the angle. So we can only going to use cos. So cos theta equals the adjacent over hypotenuse. We want to look at the adjacent side of the triangle because that's the one we're interested in. So adjacent, which is f of x, equals hypotenuse 280 times by cos of 35. Okay, that will give me the component of this force in the direction the sled is moving in. Okay, so work done is 4, so 280 cos 35, and it's moved a distance of 3 kilometers, 3,000 meters. And we can divide the whole thing by 20 minutes, so 20, and there are 60 seconds in 1 minute, so 20 times by 60. And we use our calculator now, so make sure your calculator is in degrees, not radians. So 280 cos 35 times by 3,000. No, we'll have to try again. 280 cos 35 times by 3,000. Divide that by 20 times 60. Gives you an answer of 573 watts. And that will calculate the mean power. And that is question 5. If you have any questions or comments, please leave them below. And now we're going to move on to question 6.